Okay, this is the next lesson in geometry. The lesson is called Intro to Formal Proofs. Okay, so the first question says, what is a proof? Okay, using the deductive reasoning, geometric proofs systematically lead a reader step by step from the premises of a proof to the conclusion. So basically, you're going to be given some information. You're going to use that information to move on through a series of steps to get to what you're being asked to prove. That's what a proof is. Take the given information and any prior knowledge you have in math and try to prove what you're asked to prove. Okay? Some common types of proofs include two-column proofs, which is what we're going to do today, paragraph proofs, and flow proofs. Okay? So a few definitions to start. Okay? First definition is called a conjecture. That is an educated guess. A conjecture is an educated guess. A postulate, which we've talked about before, is a statement that is accepted as true. It's never been proven true, but it is true and everybody accepts it as being true. A statement that is accepted as true. In a theorem, that is a statement that has been proven true. Okay? A statement that has been proven true. Okay, so let's try this first proof. We're going to do 6 of them today. Okay? Our first proof is completely algebraic. This entire proof is just algebra. The algebraic proofs are easier than the geometric proofs. Okay? So this proof is all algebra. And I filled out all the statements for you. You have to fill out all the reasons. Okay? That's not always going to be the case, but I want to start with an easy one. I gave you all the statements. You have to explain all the reasons over here. Okay? So here's what we have. We're given 5x plus 2x plus 8 equals 36. That's what we're given. And we're asked to prove that x equals 4. Okay? So the way you do these proofs is you always start with your given information. This is what we were given above. So that's my first statement. And the reason 1 is always given. Okay. And now look what happened from statement 1 to statement 2. We combined like terms. We combined the 5x and the 2x to get 7x. Okay? That whenever you combine like terms, that's called simplifying. Whenever you combine like terms, we're going to refer to that as simplifying. Okay? And now look at what we're doing to get from statement 2 to statement 3. We are subtracting 8 on each side of the equation, and that is called the subtraction property of equality. So subtraction, POE for short. And then to get from statement 3 to statement 4, we are dividing each side of the equation by 7. So that is called the division property of equality. Okay. That's the first example. Try example 2. This time you're not given all the statements. You're given one statement and you're given 3 reasons. Okay. So let's start with our given information. 3x plus 12 equals 8x minus 18. And that reason was because it was given to us. And now check out what's happening. We have to go from statement 1 to statement 2. We are subtracting 3x on each side of the equation. So that is the subtraction property of equality. Now there's more than one way to do some of these proofs. So you may not have done this step first if you were doing it, but let's just finish the way it was set up. So subtraction property of equality. Then it says, let's use the addition property of equality. So let's add 18 to each side of the equation to get 30 equals 5x. Then we're going to use the division property of equality. So let's divide each side of the equation by 5 to get 6 equals x. And that's not good enough because we're not done with the proof yet. The proof said prove x equals 6. We don't have that yet. Your last statement has to be exactly what you asked to prove. So we have 6 equals x now, and now I can go to x equals 6. I can just switch these around. Remember, you can just switch those around. That's called the symmetric property of equality. Okay. So again, those first 2 examples, those were entirely algebraic. We did not do any geometry in those proofs. All those proofs required was algebra. Now this next proof is going to require some geometry. Okay. So given AB equals 3 and AC equals 12, so given AB equals 3 and AC equals 12, that was given to us. We have to prove that BC equals 9. Okay, so here's statement 2. We're given that AB plus BC equals AC for statement 2. So what is that reason? There's a name for that. We talked about that in the last lesson and in the first unit. Whenever you add up the 2 small segments and you say it equals the entire segment, that is called the segment addition postulate. Okay. Then it says, reason 3, we're going to use the substitution property. So what I'm going to do is I'm going to substitute AB equals 3. So I'm going to substitute 3 into AB. You don't know what BC is yet, but I'm going to substitute the 12 in for AC because we were given that. Remember, we were given those 2 statements? So that's my statement 3 with the reason 3 being substitution property. And now I can get to what I want to prove. It said prove BC equals 9. I can get there right now by using the subtraction property of equality. Okay? So hopefully as we're doing more of these, you're getting the general sense for proofs. Okay, let's try example 4. Okay, we're going to be given 3 pieces of information for this proof. So let's put them all in statement 1, and reason 1 will be given. So NM equals 2x. MO equals 3x minus 9. And we have NO equals 4x minus 4. Reason 1 given. Statement 2, we can say that NM plus MO equals NO. That is called the segment addition postulate. Okay? Then we're given statement 3. Look what happened. They replaced NM with 2x. They replaced MO with 3x minus 9. And they replaced NO with 4x minus 4. So that is the substitution property. Remember, substitution is just called substitution property, not of equality, not of congruence, just substitution property it's called. Then we're going to simplify in the next step. That means we're going to combine like terms. I'm going to get 2x plus 3x is going to become 5x minus 9 equals 4x minus 4. Now, you're on your own for the last 2 statements and reasons. But what I'm going to do is I'm going to subtract 4x on each side. So I get x minus 9 equals negative 4. That's called the subtraction property of equality. Now I'm going to add 9 to each side to get x equals 5, which is what we were asked to prove. So perfect, and that's called the addition property of equality because I added 9 to each side of the equation. All right, next example. Now we're going to be doing that similar thing, but with angles. So write all your givens for statement 1. Okay. Reason 1 will be given. If you want to mark the diagram, you can. That's up to you right now if you want to mark this one. Let's just do it. Why not? Okay. 4x plus 2 is JKM. This small one right here is 4x plus 2. And MKL, this other small one, is 5x. And the entire angle JKL is 65. So my next step, I'm going to say this. I'm going to say that the measure of angle JKM plus the measure of angle MKL equals the measure of angle JKL, the entire angle. And that is called the angle addition postulant. We did that in the previous lesson, and we also did that in the first unit. Now I'm going to substitute in the next step. I'm going to replace JKM with 4x plus 2. I'm going to replace MKL with 5x. And I'm going to replace JKL with 65. So that's the substitution property. Next step, I'm going to combine like terms on the left side of the equation. I'm going to combine the 4x and the 5x to get 9x plus 2 equals 65. So that's called simplifying. Whenever you combine like terms, you can just put simplifying. You can also write combining like terms instead if you want, but simplifying would be the better way to write that. Next, let's subtract 2 on each side of the equation to get 9x equals 63. Subtraction property of equality. And then let's divide each side by 9 to get x equals 7, and that is the division property of equality. That was what we had to prove, so you have to prove that x equals 7. That's what we ended with. Perfect. Okay, last example today. This time, you can split up the givens if you wanted. So I did that for this one just to show you that you don't have to always put the givens all in one box. So this one I put given for reason 1, reason 2. So I'm just going to split them up. I'll say O is the midpoint of NW. And then the next one I'll do OC is congruent to NO. If you combine them into one box, that's fine. Then you're only going to use 3 steps in this proof instead of 4 like I gave you. Okay, so we're given that OC is congruent to NO. Let's label that. OC with 1 tick mark, NO with 1 tick mark. O is the midpoint of NW. That means O is halfway in between N and W. So it means this half is congruent to this half. So since this has 1 tick mark, I'll put 1 tick mark here. Since O is the midpoint, I can say that NO is congruent to OW. And that is called the midpoint theorem. Okay. Since O is the midpoint of NW, the first half is congruent to the second half. And now check out statements 2 and 3. It goes in the perfect order to use the transitive property of congruence to say that OC is congruent to OW, because OC is congruent to NO and NO is congruent to OW. So OC is congruent to OW by the transitive property of congruence. And that is the end of that lesson. That lesson was called Intro to Formal Proofs.